So some other topics under sight distance is there, such as intermediate sight distance, headlight sight distance, that we'll discuss in between, okay, whenever we are discussing something else. And one more thing is there, the sight distance at the intersections. That also one concept is there, that also we'll discuss later. Okay, whenever we are discussing something else, in between I will discuss. That is better for your understanding. Okay, now we are going into the horizontal curves. See, as of now, we have discussed what is happening on the straight roads, right? Whenever you are stopping your vehicle or whenever you want to overtake a slow moving vehicle, it was happening on a straight road, whether it is inclined or straight, longitudinal. Now we are going to consider some parameters for the horizontal curves. Whenever I am telling horizontal curve, there should be one more curve. What is that? Vertical curve. So what is the fundamental difference between vertical curve and a horizontal curve? In simple sense, I am telling. You are taking your steering. There is a turning coming. If you have to turn your steering, then it will be your horizontal curve. Some curves you don't have to turn your steering, but you will be on a curve motion. Simply your steering will be same, but you may be going something like this. Hilly areas, may not be hilly, the small area, but some slight inclination may be there. Gradient may be there. Then we call it as vertical curve. But if you want to turn your steering, which means on the x-axis you are going to move. Okay, you are going to turn. We call it as horizontal curve. Okay, simply if I am drawing a top view, okay, just imagine this is a top view of a road. Top view. So here it is the straight road. You are moving like this, and whenever you are reaching on the curve, you are moving in this direction. Okay, whenever we are reaching on the curve, an extra force is going to act on this vehicle. Correct now? What is that? Definitely it will be your centrifugal force. Everyone knows that, na? In lower classes we already studied. What is this force? It is called as centrifugal force. I am just denoting it as P, capital P. So only on the curves it will happen. On the straight road it is not there. Because of the centrifugal force, the vehicle will experience some problems. Mainly two problems. One is there is a chance of overturning the vehicle. The next thing is skidding of the vehicle. Your vehicle may overturn. So you can tell that this is the inner side of the curve. This is the outer side of the curve. Correct now? If the curve is like this is the inner side and this is the outer side. So your vehicle may have a tendency to turn towards the outer side. It is called as overturning. And your vehicle may skid towards the outer side. It's called as skidding. So two chances are there. What are those? The effects of centrifugal force. Effects of centrifugal force. I'm simply writing CF. First thing is your vehicle may skid. So there is a chance of skidding. The second thing is your vehicle may overturn. Okay. So whenever you are moving on a horizontal curve, we have to take care of the centrifugal force effects. Your vehicle shouldn't skid, your vehicle shouldn't overturn. So when your vehicle may be skidding and when your vehicle may be overturning, there are some conditions for that. Definitely if you are moving at very slow speed, then no problem may happen. But if you are moving at high speed, then some problems are happening. Either your vehicle may overturn or your vehicle may skid. Okay. So you can just parallelly note down these points. Now we are going to check when that skidding may happen and when the overturning may happen. That may be a 1 mark question for GATE exam. Okay. So I'm just taking the cross section of this road at the curve portion. So I'm simply telling this is my pavement width. Okay. If it is a 1 lane 3.75, 2 lane 7 meter like that. Okay. This is my pavement width. So this is the outer side of the pavement. And this is the inner side of the pavement. Let it be. Okay. So we are having our vehicle. So let it be the back side of the vehicle. Back side of the vehicle. So one tire you will see somewhere here. And the other tire you will see somewhere here. Okay. Simply I am drawing one figure. Now what happens? This is our width of the road. 3.75 meters something. Whatever it is. Okay. Now I told you centrifugal force will be acting. I told this is the inner side of the curve and this is the outer side of the curve. Okay, that is you are looking from this side. If you are looking from this side, like this you are looking. Okay, then how it will looks like. So the centrifugal force will act on this body of our vehicle. About which point the centrifugal force will act? Remember, it will be about your center of gravity. I am representing it as CG. So at the center of gravity, your centrifugal force will act towards the outer side of the curve. Okay? And what are the other forces acting on this? Definitely the weight will be acting, W. So these two are the forces acting on this vehicle. Na? Centrifugal force is there and W is also there. Okay. Now I am going to check when the skid will happen, when the overturn will happen. For skidding, how it will skid? Because of the centrifugal force, your vehicle may move towards the outer side of the curve. So whenever your vehicle is skidding, which force going to develop or which force is going to resist that skidding? Tell me. Whenever your vehicle is having a chance or it's a possibility towards skidding, yes, very good. Which force will resist that? Very good. It is the frictional force. We have already seen in the previous class. Very good, very good. So that frictional force is going to resist it. So first I am taking the skidding case. Okay, first I am taking the skidding case. Case 1. So which force is trying to pull you up, pull you towards the outer side? The pulling force is nothing but your centrifugal force P. Okay, so which force is going to resist that? Which force is going to resist that? As you said, it is the frictional force. Resisting force equal to the frictional force. But that frictional force is not in the longitudinal direction. That frictional force will be in the lateral direction or side. From the side only, that frictional force is going to happen. What will be that is equal to? The coefficient of friction into W. Obviously, we have seen that already. But what will be that F value? That F is nothing but coefficient of lateral friction. Or I can call it as coefficient of side friction because it is acting from the side. Na? If it is while applying the friction and stopping, then it is coefficient of longitudinal friction. Now it is happening from the side. So I can call it as coefficient of lateral friction F, small f. Okay. So what you can write? At equilibrium condition or when that skid may happen, whenever this pulling force is more than your resisting force. Correct? Na? Whenever your pulling force is more than your resisting force, a skid will happen. So what you can write? Skid will happen or skid occurs whenever the pulling force is more than resisting force, or I can write whenever P is more than F into W. So whenever your pulling force is more than the resisting force, definitely the skid will happen. That is, the centrifugal force is more than Fw, then only the skid will happen. If you are getting good frictional force on the road, then it will not skid because that friction will resist you while going towards the outer side. Okay, so that you remember may be asked for a 1 mark. I can also tell you one thing. If I am simply taking this W towards the left hand side, what I can write? Skid will happen when P by W is more than F. Like this also I can write. Huh? Why I am writing like that? Because there is a name for this P by W. This is the actual equation. But there is a name for this ratio P by W. It is called as centrifugal ratio. The centrifugal force divided by weight of the vehicle. We call it as centrifugal ratio. Okay. So this P by W is called as centrifugal ratio. So that also you note it down. In case if they want to ask a 1 mark question, instead of simply asking you regarding P, they can ask you centrifugal ratio, not centrifugal force. Whereas this P by W is called as centrifugal ratio. What is that centrifugal ratio? The ratio of centrifugal force to the weight of the vehicle. Okay. So now note down that also skid occurs when the centrifugal ratio is more than coefficient of what friction? Coefficient of lateral friction or coefficient of side friction. The value can be anything, but the maximum value will be 0.15 that we are going to take for design purposes. For the design purpose, we are going to take 0.15, but practically it can be anything. It depends on the road condition. Okay. If the road condition is not good, smooth road, then the friction will decrease. If it is a rough road, friction will increase. It depends on your tire also. It depends on the load also. It depends on the speed also. A lot of parameters are there. Okay. W is the weight of the vehicle. Okay. Yeah. Thank you. F into W. Now we have seen in the previous class F into W. W is the weight. How you got F into W? Whenever a frictional force is developed, frictional force equal to coefficient of friction into normal reaction. What will be the normal reaction? It is equal to weight of the body. Correct? Huh? That's why I'm writing F into capital W. Okay? So that you remember, for skidding, that is the condition. Now I have to check when the overturning may happen. Let's see, for skidding you need a force. To overturn, what you need? To skid this vehicle, I need a force only. To overturn this vehicle, what I need? Is it a force or something else? What it is? For overturning, you required a, very good, you required a moment. Correct na? For skidding, you need a force. But for overturning, you need a moment. Yeah, very good. So what is the equation for the moment? Simply force into the perpendicular distance to the point about which it is overturning. About which point it will overturn. Can you tell me? If this is the inner side of the tire, this is the outer side, it will overturn about this point, na? About the outer tire. Yes, very good. Right wheel, or I can tell outer wheel. Yeah, very good. So about the outer wheel, it is going to overturn. Okay. So centrifugal force only, definitely it is going to affect your vehicle. So the centrifugal force will develop an overturning moment. I am writing it as MO. The centrifugal force will develop an overturning moment about this point. Okay. So the second case I am writing it as overturning case. So who will try to overturn? Centrifugal force only. So what I can write? Overturning moment. Parallelly you also note it down. Overturning moment. What it will be? Force into perpendicular distance. What is that perpendicular distance? The distance between this force and this height. I am putting it as small h. Okay. So P into small h. What is that small h? Nothing but the height of your center of gravity above the road surface. Okay. So you can write, why not W will create moment? Yes, definitely W will create a moment. That moment will be in the opposite direction. Huh? This is in the clockwise direction which tries to overturn. The W will create an opposite moment. Correct? Na? In the anti-clockwise direction. That's what that will do. That will create the resisting moment. Very good. That will create your resisting moment. Here your friction is going to resist the skidding force. But here there is a moment required in the opposite direction to resist the clockwise moment. Correct? Na? So that resisting moment will be what? Resisting moment will be the moment which created resisting moment. Resisting moment, I am writing MR, will be equal to W into the distance. What will be this distance? If I am telling the width of the vehicle is B, or distance between two tires is something small b, weight will be exactly acting at the center, na? So can I write it as something b by 2? I'm just marking like this. I hope it is visible. Okay, I'm marking it as b by 2. This is b by 2, or this is also b by 2. What's total width is small b. Okay, so W into b by 2. You write what is h? H is the height of your center of gravity above the pavement surface, and B is the distance between two tires. Okay, if they are giving that it is the width of the vehicle, then also it's almost same. Okay, it's all negligible only, na? So B is the width of, or B by 2 is the distance between line of action of the weight to this outer tire or right tire. Okay, now what I can write? Overturn will happen. I am simply writing OT. Okay, overturn will happen or overturn occurs when the overturning moment is greater than the resisting moment. Correct na? So whenever pH is more than, that is whenever pH is more than W into B by 2, the overturn will happen. That also you note it down. Okay, yes, very good. Now like that, can I write this also in terms of centrifugal ratio? If you are writing in terms of centrifugal ratio, what will happen? Overturn will happen if P by W is more than, W will come here, H will go there, then I can write B by 2H. Overturn will happen if the centrifugal force ratio or centrifugal ratio is more than B by 2H. The width of your vehicle or width between your tire divided by 2 times the height of center of gravity. Such points can be asked for 1 mark or some true or false statements. Okay. So to resist overturning, what we need? We need more width of vehicle or we need a very less height of center of gravity. Is that possible practically? Can you give a very large width of vehicle? Absolutely not. IRC already told us there is a limit of this B. Remembering in the previous classes, in the previous class we discussed what can be the maximum width of a vehicle. Remembering how much it is? 6 meter is what? It is the length. It is the length of wheelbase, length of the vehicle. This is the width. Yes, very good. It's not 6 meter. Don't get confused. 6 meter is what? It is the average length of vehicles. The average length. It can be more, it can be less. Okay. Width of the vehicle. Maximum width of the vehicle is very good. 2.44 meter as per IRC. That's why we were giving some 2.5 meter width for the shoulders. Remembering previous class. So maximum to maximum I can give 2.44 only. Okay, previous class we already discussed that. So we cannot increase the width or the value of B like anything to reduce the overturning. What about H? Can you decrease the height like anything? Not possible. We need some height, definitely our roads will be having speed breakers, like bumps will be there, humps will be there. So we cannot reduce the height like anything. We need some clearance definitely. Our roads is designed for heterogeneous traffic. So we have to limit the speed sometimes. Correct? Na? We can't decrease H value like anything. So practically it's not possible to resist the skid like anything because we are having a maximum value for design F value. We can't increase the friction like anything. Na? The road should be smooth also. This also not possible practically. Then what we will do? We have to give some arrangements on the road to resist the skidding and to resist the overturning. That is nothing but the super elevation. Okay. Once again, I am just giving one more a brief idea. When skid will happen? Whenever this pulling force P is more than the resisting force F into W. So I can write like this: P by W. Whenever the centrifugal ratio is more than the coefficient of lateral friction. Okay. When the overturn will happen? To have an overturning, there should be a moment instead of force. So who is making you to overturn? Definitely centrifugal force. So the overturning moment is nothing but P into the perpendicular distance to about which point it is overturning. It is overturning about this right wheel or outer wheel. Okay, about this point. Okay, two front wheels are there, na? So about that point it is going to overturn. So that will be P into H, where H is the height of your center of gravity. Okay. Resisting moment. Who is going to resist? The weight is going to resist. Because it is in the clockwise, weight moment will be in the anti-clockwise direction. So W into this distance. What is that distance? Half of the distance between two tires. So W into V by 2. Okay. So if P into H is more than W into V by 2, overturn will happen. Or in terms of centrifugal force ratio or centrifugal ratio, I can write P by W. If it is greater than V by 2H, then what happens? Overturn will happen. So to resist skidding, we need more friction value. To resist overturning, we need more V by 2H. Correct, na? But practically it is not possible. That's why we have to give super elevation. See, have you seen the Formula 1 car racing and all? Correct, na? What is the how the shape of that car? If this is the road, that the vehicle will be almost like this, na? Like this will be the vehicle. There will not be any clearance, very minute clearance only, na? Because the track is designed in such a way, there is no bump, nothing. So that the center of gravity, the car also will be almost like this, na? Very flat car. The drivers will be almost sitting on the road. You can see, correct, na? If you have seen the Formula 1 car racing and all on TV. Okay. So the center of gravity of such a racing car is very less. So H value, if H value is very less, what is happening? It is getting more resistance. Okay. If H value is very less, overturning moment is very less. Okay, so there is no chance of overturning. This one advantage they are getting from the dimension of the vehicle. Also, we are making the track like that. We will give some super elevation. That's why even if they are turning the curve at some 100 km/h and all, they are not overturning. Right now in racing and all, they are overturning. They are turning the curve at very high speed. You can see that 100, 120 and all. But if you are trying to turn a curve at some 100 km/h, definitely you will overturn. Correct? Na? That much speed we cannot take because our roads are designed for heterogeneous traffic. All the speed ranges we are considering. But for racing tracks, what is the difference? Racing track is designed for very high speed. So even if you are moving at some 100 or 150, you will not overturn because the track is already designed for such higher speeds. Okay, that is the difference. Also, it is getting an advantage here. H is very less, so that the overturning moment is also less. Okay, such points you remember, some practical things. Maybe you may get such questions in interviews and all, PSU interviews and all. Okay. Moment due to reaction force. Which reaction force? Are you telling the reaction force means this Ra and Rb, na? Ra and Rb is nothing but the weight. Ra plus Rb is equal to the weight, na? So it is same. Okay, and also frictional force may develop, but frictional force is in this direction, na? So the line of action and this point are same. There is no distance between frictional force and this point. So that is also 0. In left tire, which force act the resisting moment? And left tire, nothing. It is going to overturn. How it will overturn? If I am drawing again here, this is what we have drawn, na? If it is overturned, it is going to overturn something like this. Something like this, na? Your tire will be like this. So about which point it is overturning? A moment means what? It's a force acting about a particular point. About which point it is rotating. About that point only a moment will act. It is rotating about the outer wheel, not about the inner wheel. So the moment will be acting about this point only, outer wheels. Okay? Understood? So remember such points, any true or false statements can be happening. Why not turn about left tire? See, in which direction the centrifugal force is acting? About this point only the centrifugal force is acting. Huh? Then it will turn about that point only, no? How I can show you an example? See, this is your vehicle. Okay? So your vehicle is somewhat like this. Okay? Somewhat like this. About which direction the force is acting? Towards this direction. If this is your vehicle, if the moment is towards this side, how this vehicle will move? It will move towards like this only, na? Then it will be about the right tire only, because the centrifugal force is acting towards the outer side of the curve. It is not acting inner side. If there was a force towards the inner side, then it will turn about inner side also, inner tire also. But our centrifugal force is acting towards the outer side, so it will be turning about the outer tire only. Both the forces act But in the figure, both the force act as overturning force at the left tire. Sorry. In figure, both the forces act as overturning force at left tire. Which left tire? See, overturning means what? About which point it is going to overturn. Correct now? This is your vehicle. This is our vehicle. Your force is going to act like this. If there is a moment, how it will overturn? If I am trying to apply a rotating force here, it will overturn like this only, na? About the outer tire only it will overturn. The inner tire will go in the air. Understanding? Whenever you are studying the overturning, about which point it is going to rotate. About that point only we are going to calculate. Na? The left tire will raise. Just imagine you are going on the road on a curve. You might have already experienced na? So many trucks and all, they are overturning on curves. How they are going to overturn? They will overturn like this. The inner tire will go towards the air and the outer tire will touch on the road itself. Outer tire will not go above the road. Outer tire will touch on the road and the inner tire will raise and it will go like this. Finally you can see like this. Correct now? Because the overturning or the force is towards the outer side. Since the force is towards the outer side, it will turn. It is like this. See, it is like this now. Since the force is towards this side, about this point, about the outer point, it is going to overturn and finally it will come like this. From this position, it will come like this. Now understood? Okay. So about the outer tire, it is going to overturn. Understanding? Now, practically it is not possible to resist the overturning effect or skidding effect. As we discussed like this, we cannot increase the B value. We cannot increase the F value like anything because there is a standard value, maximum value. This is why we are going to give our super elevation. Okay. So that will be our next concept. This you remember. They may ask for some true or false statements. Okay. Remember these things. This is why we are giving super elevation. So simply don't study directly super elevation. Why we are giving super elevation, that we should know first. And only there is meaning of studying super elevation. Huh? So understand all the concepts, then study, then most of the things you will not forget. That is more important for us. You should remember the things in the examination hall also. That 3 hours determines how much mark you are going to get. So understand all the concepts, then you will remember everything. Okay.